Hi, thank you for coming. My name is Dongjun Hyun. I work for Hortonworks Spark team.
Hi, I'm Jason Deere. I'm part of the Hive team at Hortonworks.
Yeah. Yes, yeah. Today, we are going to talk about more seamless access control with Apache Spark and Rangers. So this is the agenda of this talk. Let's start with the current security issue about the Spark SQL. The security is one of the fundamental features for enterprise adoption. So it is because of multi-tenancy. The billing team, data science team, and regional marketing team in a single company should see the customer data. But some sensitive data like credit card number and social security number should be handled in a different way. So more specifically, in the SQL world, the security means row and column level access control for each SQL user. So for example, for regional marketing team, only see the subset of customer filtered by their own regions. And also the credit card number should be masked safely for them. In addition to that, if we change the policy on time, then we must enforce it to various SQL engines simultaneously. The latest HTTP provide Spark 2.1 and 1.6 and Apache Hive 2.1. But at least 3 SQL engines work together in this environment. And also user choose one of them for their purpose. For ETL or interactive analysis, they can choose any of them. So we must provide the security consistently. The first issue is Apache Spark is general data processing engine. So if Spark can read a file, it can do anything. For example, in this case, it just direct access the warehouse. So it means read every rows and every column. So there is no security, the fine-grained security here. So in other words, all Spark SQL user can see the same result from the same data. So directory and file-based permission are insufficient for fine-grained access control. So this is the one of the main reasons the Apache Spark does not support this kind of standard SQL authorization until now. So the other issue also starts from the storage. This is an example of a warehouse with the permission 777. It means allowing everything. So in this case, it happened because not only Hive, but also Spark can access this warehouse and manipulate the data. So we give it away. So in order to give some permission to some user from part of data, in this case, the whole warehouse becomes vulnerable. So in a secure cluster, permission 700 like this is more better choice. The last issue is the overhead during starting or maintaining the security policy in your company. So basically, do we need to make another set of policy for SQL, Spark SQL? Absolutely not, because this is a SQL security and Hive already provide a set of rules. So the best choice is we reuse them. Another situation is Spark can use a special data source to access that kind of secure data. But in that case, it means rewrite the Spark application. It happens for the case of a view. If you introduce a new view, then we need to at least you should rewrite the SQL string from every language. But in that case, Spark have 4 languages, Scala, Java, Python, R. In every language, you should change the program and also verify that. This is not an easy way of transition for security. So what we want is just turn on and off very easily without any change. The last option is it is also used. In some case, we duplicate the data. You can imagine that the data marked for each team. So you can copy the original data and masking, filtering, and do everything and provide that each department. So in that case, in worst case, if we change a policy, you need to rebuild everything from the bottom. It is a waste of many resources. So let's move on to our goal. So here is the Python Spark app, use Spark sessions, and use SQL. So it tried to access the table T customer inside DB command. So what we aim is, without changing this app and without changing this database, just provide the security, row and column level security. In this case, this is a batch app. The second goal is to provide the same thing in the interactive analysis. You know, as we know, the Spark provide various shell for Scala, Spark shell, and for Python, PySpark, and also for R, Spark R, and the SQL, the Spark SQL. So at least there is 4 interactive shell. For this interactive shell, without any effort, you want to provide the security things. Also, Spark provides another interactive environment. It is Spark Script server. So Spark user using Spark Script server through Beeline or Javelin in this case, and also need to get benefit from the low-end column level security. Here is the billing user can access all rows and all the exact names. But in case of data science, it only see the mail customer and can see the first 4 characters of the name. So before going further, I want to show something live. So I bring the demo here. So you can log in the Javelin with billing account and go to billing notebook. So here, if we execute all the query, this is using the Spark Script server. So you can see the billings can see every database and every tables and the rows, exactly the value. But at the same time, if we log in the data science account, this is data science notebook. All the query is exactly the same. There is no view. This is just table, and the policy is dynamically applied. But the database only DB command is there, and the row is also different. This is the interactive environment also, the Spark shell and the PySpark. When you use the SQL string, the result is come here. So you cannot access directly the file, but you can resort the data securely. So here, behind the Ranger. The Ranger access, Ranger govern everything in the Hadoop ecosystem. So we reuse the Hive thing. So let's go to the Hive plugin. So here is I added 2 access rule and 1 masking rule and 1 row level filtering for this demo. So let's look at details. So currently, we show only male customer, but we can change this into female for a female target marketing and save it. Also go to the filtering. For the female user, the name is more important than male, so we want to hide everything. So previously, it is so first 4 character, and now it hashes, so nobody can see the exact woman's names. So everything is applied. So go back. In the same session, this session is still continue, but when you execute the same query, the result is the female customer, and name is hashed. Yeah, so this is the expected result. And also, in the Javelin notebook, it is the same. When we run this notebook, and the result is the same. You can see the hashed result and the male result. This is data science account. And for the billing, there is no access rule for billing, so everything is the same. Every database and every load, we still get the money from this customer. So this is the brief overview. And so later, now the Jason will provide the deep dive things.
All right, thanks, Dongjun. All right, so I guess I'll talk a little bit about some of the technologies that we're using to implement row and column security in Spark SQL. So this uses Apache Ranger, and as well as Apache Hive with LLAP to achieve this. So I'll give a quick intro about both of those technologies right now. So we'll start with Apache Ranger. So Ranger is a platform that you can use to administer and manage security policies on your Hadoop cluster. So it allows you to define security policies on various components of your cluster, such as Yarn, HDFS, Hive. And you can also define which users and groups that the policies apply to. And so each of these components have plugins with Ranger, which basically are used to enforce the policies from Ranger for those components. So I guess Dongjun already touched on it a little bit, but I'll just kind of talk a little bit about some of the Ranger policies that exist to govern access to table data. So there is, Ranger has column access policies. Basically, you can allow or disallow columns from being read by the user. There are column masking policies. So that allows you to apply transformations on the column values rather than showing the full contents of the data. So that's, again, it's useful for sensitive data that you might not want every user being able to look at. And so some of the column masking options might be either full or partial masking of column contents, or replacing the entire contents with either a hash of the data or just with a null value. Ranger also has row filtering policies, where the user will only see rows that meet the filter condition that's defined in the policy. For example, only return rows where the state is California or something like that. So that's kind of all I'll talk about in terms of Ranger, just what policies there are that you can define in the cluster. So now I'll talk a little bit about Apache Hive with LLAP. So what is Hive? It's another SQL on Hadoop solution. It's one of the original SQL on Hadoop solutions. And so I guess the diagram's kind of showing a kind of simplified flow of what a Hive query looks like. So the entry point for Hive on LLAP is Hive Server 2. And so Hive Server 2 is a Hive query server. If you're familiar with Spark, then it's basically like the original Spark Thrift server, but for Hive. So it accepts client connections. It runs queries from the user, and then it returns the results back to the client. So Hive Server 2 is a secure service, which means if you're running on a secure cluster, the client is going to need either Kerberos credentials or a delegation token in order to connect and send queries to Hive. So when a query comes into Hive Server 2, Hive will compile the query and generate a query plan for that query. So that plan is then shipped to a Hive query coordinator, which is responsible for farming out the work for the query onto the Yarn cluster for execution, and as well as tracking the progress of the query. And then once the query has been executed, Hive Server 2 will consolidate the results and return the data back to the client. And on HTTP 2.6, we also have the option of using LLAP to perform the query execution on the query. And so what is LLAP? That is basically a set of long-lived worker daemons which are running on the Yarn cluster. And these daemons are responsible for fetching the data required for the query, as well as running the query plans on top of that data. So query execution using LLAP provides a number of advantages compared to running the queries just using normal Yarn containers. For example, you can avoid startup costs. LLAP uses asynchronous I/O, and it also can benefit from data caching as well. So that's just a really brief overview. So there's actually a lot more detail on LLAP. I guess my colleague Sergey has a talk on that later today at 5:50 p.m. If you're interested, then definitely check out that talk. He has a lot more detail about that. So Hive basically has integration with the Ranger security policies that we talked about before. So you basically just run your queries as normal, and the security policies are kind of applied automatically by Hive. For example, table and column access is checked to see if the user is allowed to access them, and it'll throw an error if it's denied. or if there's column masking or row filtering policies in place for that user, then the query plans that are generated by Hive will be automatically rewritten to apply the necessary transformations on the data. So if we look at the previous diagram with the Hive query execution, basically the orange sections kind of show the additional steps that occur on a cluster that has ranger policies defined. So basically the policies are applied by Hive server 2 during the query plan generation, where the plans will be modified to apply filtering and masking. And then the actual masking and filtering of the data will be done by LLAP when it actually executes the query plans on top of the data. So how is this useful for Spark SQL? So there is also an API that external applications can use to submit query plans directly to LLAP for execution and retrieval of the data. So just kind of showing what the flow looks like for external clients using LLAP. So Hive Server 2 is still the initial entry point. So so the client will submit the query to Hive Server 2. And like before, Hive Server 2 will compile the query and generate a query plan. But this time, rather than the plan being sent down to a query coordinator to run the query plan is actually returned back to the client application as a signed package. And so then it's actually the client application which is responsible for directly communicating with LLAP to submit the query plan. And then LLAP will run the plan and return the results back to the client. So most of these interaction details are kind of taken care of by the API. Like what the users end up seeing is like a Hadoop input format, if you're familiar with what that API looks like. So basically, the client requests a set of splits, and then the splits are returned back, and each split can be used to create a record reader that the application uses to retrieve data. And so since the query plans are generated by Hive Server 2, we still get the seamless integration with the ranger policies from the plans that are generated for the client. So the data that you receive using the external LLAP client has the same policies applied to it that you would see from normal Hive queries. And so this is kind of the API that we'll be using to implement column security in Spark SQL. So how do we put this together for Spark and Spark SQL? So we have Spark LLAP, which is a Spark connector library in addition to patches on top of Spark. And so using Spark LLAP, data is read securely by going through LLAP, and any ranger policies that exist on the tables that are being read are applied. And so I'll just talk a little bit about some of the things that Spark LLAP provides here. So first off, Spark LLAP takes care of the credentials when the Spark application is running on the cluster. So Spark LLAP requires access to Hive Server 2. And so when you're running in kind of yarn cluster mode, if your Spark app is running in yarn cluster mode, then it basically requires a delegation token to Hive Server 2. And so Spark LLAP includes a Hive Server 2 credential provider, which basically takes care of acquiring the delegation token for Hive Server 2 for the communication to work properly. It also includes a modified Spark catalog, where the table reads end up being resolved using LLAP. And so then there's no direct reading of the underlying file data for a table by Spark SQL. So just showing kind of a couple of example query plans with and without Spark LLAP. So in the top one, in the normal Spark SQL, the table access ends up using the metastore relation, which is basically the native Spark table read. And then, so with Spark LLAP, that ends up being replaced by an LLAP relation, which basically represents the table read going through LLAP. So just talking a little bit about the LLAP relation. That's basically a Spark connector library that integrates with the LLAP input format that we talked about earlier. And so as a result, you get the secure access through Hive Server 2 and LLAP, as well as your Ranger policies for column access and row filtering and column masking applied. The LLAP relation also supports predicate pushdown and column pruning. What that means is that filters and projections from your SQL query will be handled by LLAP. The advantage of that is that helps to reduce the amount of data that's returned back from the data connector to Spark, and also potentially better performance. For example, if you're doing column pruning, that you may get better performance if you're using if the tables are using a columnar storage format. So how do we use Spark LLAP? So basically, when you start your Spark app or Spark Thrift Server, you include your options to pass in the Spark LLAP library, as well as configuration settings to enable it. And really, that's it. When you run your queries using Spark SQL, the LLAP metastore catalog kicks in, and the table access is switched to reading data through LLAP rather than through the native Spark access. And so that's my part. Yeah. Take it back to Dongjun.
Oh, yes. We already showed the demos. So the Apache Spark is the fastest developing project. The last month, Spark 2.1.1 is released, so HTTP shipped the same version. So in Spark LLAP, we split the development. The JSON developed the Spark LLAP for Spark 1.6 last year. So at that time, we mainly focus on select an LLAP connector and provide this architecture. And also, since HTTP 2.6, I developed and provide the Spark LLAP for 2.1. Previously, we already developed Spark LLAP for Spark 2.0, but 2.0 is not going to GA in HTTP, so we just skip that version and just go to directly 2.1. And the last week, we released HTTP 2.6.1, and so there is Spark LLAP for that. And now we can we provide the YARN cluster mode, and we also add the Hive complex type. Also internally, we develop Spark LLAP for next version. The Spark 2.2 will be released next in a month, and also we release very soon, available in GitHub. So it is developed by another colleague, the Ming Jae, in our Spark team. So there is a resource. This is Apache license project, not Apache project. So you can check the source code in the GitHub, and the library is already in the Maven repository. So you can just use like a package. And also there is a YouTube demo you've seen in today. And there is a blog and technical article how to set up. And there is a support matrix, which is SQL syntax is supported securely. Yeah. So you can reference this architecture and try to use that. And this is the summary. The Spark LLAP with HTTP 2.61 is technical preview. And support low-end column level security with Spark app and Spark share and Spark Thrift Server. Or Spark environment, you can use this without changing the code. And also, the configuration is not much. So eventually, the last turn on and off is by one configuration. And also, the Ranger control Hive Spark, the Spark 1.6 and 2.1 simultaneously and consistently. So actually, if you use already Ranger and Hive security issue, then there is no need to add more security policy. Just use that, yeah. So this is the community effort. There is a lot of Apache Hive team's contribution and Apache Spark team, Apache Ranger, and also the following people make a lot of effort for this. So thank you. Any questions? Yeah. Oh yeah, you ask the Apache Ranger UI is provided, but you want to ask the how to use in the command line via Ranger. I think Ranger provides the REST API, but as far as I know, there is no command line UI for command line interface for Ranger, right? Do you know?
Not that I know, but is that the question? Or?
Yep.
You see this passes through HAT 2 on the way to LLAP. If I'm using an old archaic system which doesn't have LLAP yet, can I just, going through HAT 2, will I get the same security? Or there's a disjoint there?
Yeah, so that, I mean, so it could have been done using that as well, like where where you basically fetched all the data through Hive Server 2 as opposed to through LLAP. That's a possibility to do that. I guess the advantage of not doing that is that when you go through LLAP, you actually get kind of a parallel data set that you can access. Obviously, if you go through Hive Server 2, it has to go, basically Hive Server 2 has to consolidate the results and then send it back to you. But yeah, that's also, that is an option too to try, although not part of the solution.
Yep.
As far as my understanding is, we do have the policies for Hive separately from the HDFS policy. So if I want to enforce the same policies as I defined in Hive for my HDFS access, is it possible?
Oh, the question is the correlation with the HTTPS permission and the Hive permission, right? In that case, the Hive permission is override the HTTP permission.
Well, yeah, so what will happen is, so how the HDFS permissions would be set up, I would think would be, the idea would be that Hive controls access to the warehouse. And so you would most likely set up your HDFS permissions such that only the Hive user is able to access the underlying file data. And so then any kind of writes or reads on top of the Hive warehouse end up happening through Hive, which is running as the Hive user. And so how the access then I guess Hive Server 2 ends up also applying its own policies in terms of who's allowed access to read what tables, right? And so that's kind of defined in Ranger. And so when a request comes to Hive to say, hey, I want to read this table. So the Hive user has the capability to read any of the data on the warehouse, but it has to use the policies that are in Ranger to say, hey, is this user allowed to access that table? And so so Hive is going to be doing that validation.
I understand that it's must be the dual configuration, whatever you mentioned just now.
Okay.
If we do that, then you might not be able to have control on yarn process. Maybe the resource controller in a multi-tenant Hadoop cluster, we might not be able to control yarn if we use only high user.
Okay, so.
I think as far as the resources, for every component that you use on your batch, or so from the start to beginning, you have to make sure that you define policy for every component. So let's say you are running a job which involves Hive HDFS, and you're looking at this to yarn. So first you have to define a policy on your or for yarn saying that user XYZ is going to have access to this and that queue.
Yeah, next question. Oh, this is a SQL. Yeah, so yeah, before machine learning, you can extract the data from the source. So in that case, you securely access the source, and after that, you can do machine learning, and you can save into data source library into another folder. Yeah. Yes, Spark SQL. So the other access to direct that file, it will fail. Yeah, but oh, but even in data frame, there is an API, the table. The API named the table. In that case, you call the table, and in this case, the whole plan converted into SQL string again. So it is supported. Yeah, yeah. What I mean is the SQL data source is supported. So what I mean, even data frame API, it is converted in Catalyst into single optimized plan. So as you see in the slide, the plan is the data frame and the SQL string is also into one single catalog optimized string, and the physical frame is the same. So if the data source is existing in Hive Metastore, it is provided and supported. Yeah. Yeah, because the Hive is the only secure storage in Hadoop ecosystem. Yeah. Yeah, only read part is done by LLAP. After reading that, everything is done by Spark. Yeah.
When you run a job, when you run a query, by default it uses LLAP, or you have specifically mentioned that use LLAP?
Yeah, the question is, this is by default. By default, this property is disabled. So everything is the same, the existing things. So for this configuration, what is the page?
At the
Sorry.
end.
Yeah, at the end. Sorry, here. Can you see the second configuration, the Spark SQL Hive LLAP true? If that configuration is true, in that case, it works. But this is only supported the command line and the configuration environment. So while working the Spark application, you cannot switch it, turn off and turn on the security thing. Before starting the app, you should specify that option as true. In that case, you can access the secure storage.
It depends on your, also if you're running on a platform that has LLAP enabled, then yeah, depending on what the settings you have for when you run Hive, then yeah, the Hive queries also will be executed through LLAP. Is the LLAP setting at the cluster level? It is defined at, it's defined in Hive Server 2. It's a Hive Server 2 setting. Actually, you can actually disable it at the query level, I believe. But yeah. No, so if you're interested in an LLAP, then definitely check out the talk at 5:50 today. Sergey will be giving a big talk on LLAP, kind of the latest developments, also numbers in terms of kind of the latest benchmarks that they ran and stuff like that. So he does have stuff like that if you're interested.
Oh, the Spark LLAP is still technical preview. So because we want to prepare for Spark 2.2, it will be released the next month. We want to release ACP 2.6.2, the second version. At that time, we want the GA Spark LLAP 2 with the Hive against Hive 2.2. So we postponed that until now. So the Spark is GA, the Spark LLAP is a technical preview.
No, so Hive on LLAP is, I believe that one is announced as GA, right? Like Hive on LLAP. However, the solution here, the Spark and LLAP solution here for Spark SQL, so that one is, that's what's tech preview.
Yeah.
Yeah.
Yep.
On your LLAP relations on your talking about the column, is that so you can get better performance when querying
I think it's just in general, it's better performance in terms of I guess it's you're basically querying less columns as opposed to returning all the columns for a table, you can just pick which ones you want, which columns you want to return back. Basically, like if your SQL query is saying only needs 1 or 2 tables out of your 100 column table, if you did not have column pruning, then what would happen would be using the data source APIs, it would return back the entire table, like all 100 columns. So basically you get improvements both in terms of the amount of data that's sent back to Spark, but also in terms of the actual data source. For example, if you have columnar formats, then if you're only fetching 2 columns, it'll be a lot faster reading just those 2 columns as opposed to reading the whole thing.
Yep.
Considering Uzi and Secure Spark.
Actually, there is no difference. If you made the Uzi job with that configuration, then the app can access the secure storage. Without that option, by default, it can just work previous Spark. So the only difference is the dash package. Yeah, that kind of. Here should be dash jar file. If you specify the jar file and give the configuration, it works. Just work. Yeah.
Any thoughts on security, trying to make sure people do that if they have access to certain parts of the cluster, but if it's not, these configurations might have full access?
So I guess the key to doing what you do is, I guess in order to properly secure the database, I guess what you would do would be, I think in the slide he had kind of showing the permissions on the warehouse. Basically, you would set the warehouse permissions such that only the Hive user is able to access the warehouse. And so at that point, if you basically disable this stuff and Spark tries to perform a native read, it's gonna get an access error, right? Because it can't open the files. And so basically, if they don't have the switch, then they're kind of dead in the water.
Yeah. So maybe it's running out of time. Is there any question? Then, thank you. And also the conference organizer would love your feedback on my session. So please rate some information on the apps. Thank you.
Thanks.